Hello friends, welcome to Tips and Tricks in Mathematics. This is for class 11 students and the topic of discussion is permutations and combinations. In this video, we'll be focusing on the NCERT solutions for exercise number 3. In the first problem, we need to find how many 3-digit numbers can be formed by using the digits 1 to 9 if no digits is repeated. So we can use the permutation formula PNR, which is n factorial by n minus r factorial. So what is n? There are 9 digits. So n is 9. 3 digits are to be selected. So r is 3. So n objects and out of that 3 are to be selected. So we use the formula, put 9 factorial by 9 minus 3 factorial, 9 factorial by 6 factorial. So 9 factorial can be expanded as 9 into 8 into 7 into 6 factorial. We stop at 6 factorial because denominator also 6 factorial is there. So this will get cancelled. Final answer will be 9 into 8 into 7, which is 504. How many 4-digit numbers are there with no digits being repeated? So let us take this as the 4 digits. This is the unit place and this is the 10th, 100 and this is the 1000 place. Now it is important to note that in the 1000 place 4-digit number 0 cannot come. So there will be balance 9 digits remaining. Total there are 10 digits from 0 to 9, but in the unit place, in the 1000 place 0 cannot come. So there will be only 9 possible ways. So that's why we have written in the 1000 place or the first place there are 9 different ways. Now one number is already gone here in the 1000 place. So in the 100th place or in the second position we have remaining 9. Why 9? Because now 0 can be included in this. So in the second position there are 9 ways. Similarly in the 10th place the 2 digits are already gone, so there will be 8 ways. In the unit place now 3 digits are gone, there will be 7 ways. So total 4-digit number is 9 into 9 into 8 into 7, which is 4536 ways. Now how many 3-digit even numbers can be made using the digits 1, 2, 3, 4, 5, 6, 7? Even digits means what are the even digits possible? In the unit place it has to be either 2, 4 or 6. So there are only 3 possible ways in which unit place number can be filled. So we have written in the units 3. First 2, 4, 6 only can be filled because they are even numbers, 3-digit. Now 1 digit has gone here. So balance there are total 6 digits. So there are 5 different ways possible to put a number in the 10th place. Now 2 digits are gone. 2 numbers are gone. Now balance is 6 minus 2, 4 ways in the 100th place. So total number of 3-digit even numbers will be 3 into 5 into 4. Find the number of 4-digit numbers that can be formed using the digits 1, 2, 3, 4, 5 if no digit is repeated. How many of these will be even? So first we have to find the number of 4-digit numbers using the digits 1, 2, 3, 4, 5. So n is 5 and we have to take 4-digit numbers out of which 4 are to be selected. We use PNR formula, n factorial by n minus r factorial. N is 5 and r is 4. So 5 factorial by 5 minus 4 factorial, 5 factorial by 1 factorial, 1 factorial is 1, 5 factorial is 120. Now in the next part we will find how many of these will be even. Out of 120, how many will be even? So even for even number in the unit place, the number has to be either 2 or 4. So in the unit place there are 2 number of different ways in which number can be selected. So this is filled. Now in the 10th place 3, 4 there are 5 digits. 1 is already gone, so 4 number of ways in the 10-digit number can be filled. Now 2 digits are gone in the unit and 10th place. Balance will be 3 digits. Out of 5, 2 have already been filled, so there are remaining 3 ways. Similarly in the 1000 place another 2 ways will be there because 3 digits are already filled. So final answer will be 2 into 4 into 3 into 2. So these are the number of 48 is the number of 4-digit even numbers out of 120 possible. From a committee of 8 persons, in how many ways can we choose a chairman and a vice chairman? So we need to choose a chairman and a vice chairman out of 8 persons. So n is 8, r is 2. We use the formula PNR where n is 8 and r is 2. So it will be 8 factorial by 8 minus 2 factorial, 8 factorial by 6 factorial. 8 factorial we can write it as 8 into 7 into 6 factorial. We stop here because we see denominator 6 factorial. We cancel that. We get 56 ways. Now in this problem we need to find n if n minus 1 P3 and P4 is equal to 1 is to 9. Now let us first try to solve this. We know that PNR formula is n factorial by n minus r factorial. Here instead of n we have to write n minus 1. So n minus 1 factorial by n minus 1 minus 3 factorial. So this will be n minus 4 factorial. This can be written as n minus 1 into n minus 2 into n minus 3 into n minus 4 factorial. This will get cancelled. So this will remain n minus 1, n minus 2 into n minus 3. Similarly, Pn4 also can be written as n into n minus 1, n minus 2 into n minus 3. Now this is in the ratios. So a by b is equal to 1 by 9. So this, let this be a, this is b. So a by b is equal to 1 by 9. So this divided by this will be equal to 1 over 9. That's what we have written. This divided by this is equal to 1 over 9. Now we substitute the values of n minus 1 P3 and n P4 previously. We can easily compute n as 9. Find r if P5r is equal to twice P6r minus 1. Now it is very important that to find r is always lower than the n value. So n value here is 5 and here n value is 6. So whatever r we get should be less than either 5 or 6. Since 5 is smaller than 6, r should be smaller than 5. Please note that r can never be greater than the n value. So r has to be smaller than the n value. This is very important because in this case we will get r as two values. We will get solving some quadratic equation. We will see that. Now we use the formula PNR n factorial by n minus r factorial. We solve this. P5r is given by this formula. Similarly P6r minus 1 is by this formula. Now we substitute these two values in this equation. So 7 minus r factorial by 5 minus r factorial is equal to 2 into 6 factorial by 5 factorial. How do we expand this? So this will be written as 7 minus r into 7 minus r minus 1. What is 7 minus r minus 1 is 6 minus r. Similarly into 5 minus r factorial. So that this will get cancelled. We will reach this equation. This is a quadratic equation. We have to solve it. Let us do that. So we will get r square minus 13r plus 30 equal to 0. So through factorization we can get the roots as 3 and 10. So r minus 3 into r minus 10 is equal to 0. So r will be 3 and r equal to 10. We know that r cannot be 10. Why? Because then it becomes greater than n. So this condition has to be ensured. So r equal to 3 is the final answer. How many words with or without meaning can be formed using all the letters of the word equation, using each letter exactly once? So number of letters in the words 1, 2, 3, 4, 5, 6, 7, 8 letters are there. So we have to use all the letters. So n will be 8 and r will be 8. So different numbers can be formed is PNR formula where n equal to 8, r equal to 8, 8 factorial by 8 minus 8 factorial. This is 0 factorial in the denominator, which is 1. 8 factorial is 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. This will give us 40,320. How many words with or without meaning can be made from the letters of the word Monday, assuming that no letter is repeated, if 4 letters are used at a time? So Monday, how many letters are there? 1, 2, 3, 4, 5, 6 letters are there. So N is 6. We have to use 4 letters. So R is 4. We use the formula PNR. N factorial by N minus R factorial. 6 factorial by 6 minus 4 factorial. This is 2 factorial. So this will be 6 into 5 into 4 into 3 into 2 factorial. 2 factorial will get cancelled. 6 into 5 into 4 into 3. Answer will be 360. In the second part, same problem is there, but if all letters are used at a time. So clearly there are 6 letters, N is 6. Now R will be 6. R is 6, N is also 6. The number of different words will be P and R. P6, 6. Total number of different words will be 720. This is 6 factorial. The answer for this is 6 factorial. 6 into 5 into 4 into 3 into 2, which is 720. In the next part, we have to use all letters are used, but first letter is a vowel. This is very important. Vowel, what is vowel? A, E, I, O, U. So we search in this word. A is a vowel, O is a vowel. So there are 2 vowels in this. Now they are to be used in the first letter. So first letter, let us start with O. The first letter is O. There are 5 remaining letters to be filled. 5 remaining letters to be filled from the remaining 5. So which will be 5 factorial. N is 5, R is 5. So we will get number of different words as 120. Similarly, when A is to be put as first, again we will get same. A as the first word and 5 factorial will be the remaining 5 letters to be selected from the remaining 5 digits. So again we will get 120. So total number of words with first letter being vowel is 120 plus 120, which is 240. In this problem, in how many of the distinct permutations of the letters in Mississippi do the 4 I's not come together? So total number of permutations when 4 I's do not come together is total permutation minus total permutation of I coming together. So first we need to find total permutations, this one. So how do we find? Here we see that many of the letters are repeating. For example, there are 4 I's, 4 S, 2 P's and 1 M in this particular word. So since letters are repeating, we use the formula n factorial by P1 factorial, P2 factorial, P2 3 factorial. So total number of alphabets is 11 in this word. There are 4 repeating words in S, P. So we put as P1 as 4, P2 as 4 and P3 as 2. 4 I's, 4 S and 2 P's. So we use the total permutation can be formed using this formula. N is 11, P1, P2, P3 factorials are 4, 4 and 2 respectively. We substitute and get the intermediate answer as 34650. This is the total combination possible with these words. Now we find total permutations of I coming together. First, although in the final question we have to find I's do not come together, but first we find how many are coming together, then subtract it from the total permutations. So we take 4 I's as one word. So we put 4 I's as one word or one letter, we can say, and put it in this blue color. So remaining there will be 7 letters remaining. 7 plus 1, this has one object. So there will be total 8 letters we can say. These 4 I's we are taking it as together. Now again we use the formula same. So here P1 is 4. 4 S's are there. 2 P's are there. 1 this object and 1 M object. So total 8 are there. 1, 2, 3, 4, 5, 6, 7 and this one is the 8th object. So we get number of permutation with 4I together n factorial by P1, P2 factorial, 8 factorial by 4 factorial, 2 factorial. On simplification, we get this as 840. So total number of permutations of 4i not coming together is total permutation minus total permutation of I coming together. 34650 minus 840 is 33810. This is the final answer. In this problem, we need to find how many ways can the letters of the word permutations be arranged in the word start with P and end with S. So there are 12 letters in this word, but first and second position is fixed by P and S. So remaining 10 letters, we need to find how many ways it can be done. Since some of the letters are repeating, for example, T is repeating 2 times. So we use the formula n factorial by P1 factorial, P2, P3 factorial. Here n is 10 because P and S are fixed. So balance 10 letters are to be adjusted. So there are 2 T's, so P1 will be 2. Total arrangements will be 10 factorial by 2 factorial, which is 1814400. Friends, with this we conclude this video. Please like and subscribe my channel so that in future more videos can be released to you instantaneously. Thank you very much, friends.